This is Headrush Gigboard processor, but if I turn it on the back side, there is a missing board. And here is the missing board, but check this out. Oops. Hey everyone, I'm Nicky from An Audio, and usually I'm cabinet switchers, but a friend of mine gave me this Headrush Gigboard for repair. I thought it's a pretty simple problem with the power supply sections or something like that. I don't know. It's gonna be easy to repair. And he told me the display doesn't turn on and there are some lights on the LEDs when the first power on and nothing happened. So I thought I will spend, let's say, 20-30 minutes to fix it, but unfortunately it takes much more. Let's start from the beginning. So this is the main board or the motherboard or whatever you want to say it, and it drives this board, which has a processor over here, and this is the analog board including some DC to DC converters and the ADC and the jack as well. And what I did, this is the cable from the display, and I plug it on this board and try to power it on, but it doesn't start. So I thought the problem is here. And I did some investigations here with all this power supply here and here, but I wasn't able to find anything, so I contacted with Headrush to support. Unfortunately, they told me their engineers or technical guys are too busy and they can't provide their schematics. If I find them on internet, if I find them on internet, just not I can use it, but they can't give me anything. So it's a little bit strange for me. And anyway, so I need to investigate everything from beginning. So I'm gonna put this board here, and I'm gonna take that processor board, or yes, this is a processor board, and that board actually is not designed by iMusic or Gigboard or something like that. This is the part number. This is the model. It's Raxda Rock 2 card, and this is computer on board card. You can run Linux or whatever you want. And the good part is there is a schematics on this board. Also there is a component placement where you can see what's going on, and that helped me a lot until I removed that chip. And there is a reason why I removed that chip, but firstly I'm gonna turn on this board and I'm gonna show you what I measured across it, because it's the first step I did before doing that video. So before start to testing what is going on here, let me explain how this board actually works. That switch is actually a momentary, it's not a latching switch, and every time when I press it, there is a anyway, I'll turn this off. As you can see, they are not thick traces over here, so anytime when I turn it on, there is a bunch of components, probably RC network and some transistors, that turns on this transistor. I believe it's a MOSFET. I don't know what's the model number, and I don't care actually. So when I plug it here, this is the ground, and when I measure, let me see what we have here, 18 volts, so this is probably the output. Let me try that. Yes, so it turns on for a couple of seconds, then turns off, and I believe that there is a latching circuit, and that time is necessary for that processor board which is missing right now to start. And when it starts, actually it gives a voltage back to the MOSFET to keep the MOSFET on, and when I press it again, if I want to turn it off, it gives some voltage or some signals to that processor board, and then it turns off. So to be able to measure the voltages across that board, I need to press it, yeah, something like that, sequentially. So here we have a couple of different switch mode. There are buck or step-down converters. I can recognize them by the inductors, this, and this one. And the easiest way to find what's going on here is actually to find the capacitor next to those inductors. So if you see, there is a capacitor here, and let me try. So we have 5 volts here, and there is a linear regulator. So we have 5 volts here, 1.8 volts, and this is the ground probably. Let's move here, and this is the inductor, and I saw there is a 0 ohm resistor, so I believe this is a series resistor. It acts like a fuse. So we have 3.3 volts here, and here we have the same resistor. Anyway, I hope you can see it on the bottom, and this is for that power supply section, and it gives 1.2 volts. So I believe here everything is fine. On the right side there is another step down converter, so let me try to find the right. Yes, I have 1.8 volts here, so I believe everything here is fine. And on the back side there are a lot of missing components, but I recognize this is the clock, and here is a battery for it. And what I found, that this board actually is used on 3 devices. This is the Geekrig, and a device from Akai, and a device from Denon, if I'm not wrong. And they have different connections. This is probably, let me see, this is probably a network, or this, I'm not sure. Maybe this is USB connector, and there is some kind of wireless communication. Anyway, I thought this board is okay, so let's move to that one, which is more interesting, and why I removed that chip. Lucky enough, there is a schematics on this board. It helps me a lot, as I told you. So here we have, just 1 second to take a screwdriver. Here we have 1, 2 separated buck converters, and this is a special chip that delivers a lot. It actually delivers 13 different voltages for the processor itself, and there is probably a sequence of turning on of all of these voltages. So I started to check what's going on here, and I found that some of the voltages are missing. here we have, if I'm not wrong, let me show you just for a second on my computer. Let me see the correct page. This is the schematics. Yes, this one, and just to zoom it a little bit, and as you can see, there is a table showing the different voltages, and this is the big system power chip, and all of these voltages are written here. Here we have, this is the CPU supply chip, and here is the GPU. And let me show you on that table. On that table I can see what should be the voltages. What should be the voltages? So for example, the CPU voltage VDD is GPU voltage is 1.1 volt, and there should be the CPU voltage, but I can't see it right now. GPU, it's red. Anyway, the CPU and the GPU voltages both of them are 1 volt. Yes. Anyway, let's move back to dot board, which is more interesting. So I found that there is a short between that voltage, which in my case it was I forgot what was that voltage, but it appears to be 2 volts or something like that, and there was short, and there were some missing voltages as well here, and I soldered 2 wires from here, and using my external power supply I turn here 1 volt. I just sent 1 volt to that board with roughly about half amps, and I started to check with my FLIR thermal camera what's going on, and I saw that the area under that processor is getting hot, but it wasn't a specific capacitor, which I was happy to see a red hot capacitor, but it wasn't. So I decided to desolder that chip, and after did it, there wasn't anywhere short here. I haven't powered that board without the processor because I believe that it gives some communication with that power supply management IC. So to work it correctly, I need to solder that new chip, which I bought from AliExpress. And also I took this stencil, but when the chip arrived, I saw it has already all of these balls. So my next step is to try to solder the new chip, and here is pin 1, and here is the mark of pin 1. It's supposed to be like so, and right now I'm gonna solder that chip. I think I did it, and there is no short anymore across that capacitor I have before. It reads in that direction. Let me show you. It reads something in the megom range, and it's 40k in the other direction. So I'm gonna put that board as it was. Nice click. So I need to screw a couple of screws before doing everything, but I think I'm ready to do the first test. And I'm gonna change the thermal paste. So here we have a screen, like, you know, maybe it's like so. Yes, it looks better. And now the heatsink. Yes, I haven't tested, and this is gonna be the first power on, and I hope it works. But to do that, I'm gonna use my power supply, external programmable power supply, where I set the current and roughly about half amp. So this board sits like here, and there are two connectors on that side. Let me try like this. It's gonna be easier for me. Like so, like so. Okay, and this is the screen, the display. Do I have here's the touch screen. Okay. What else we have? A cable with two pins. It goes here, and this is the USB cable that connects that board. Okay, I'm gonna screw these two screws. I don't want to have some loosey boards. Come on, come here, and let's try the moment of truth here. And it runs. What was that? What? Come on, come on. Maybe I need to increase. Let me see what's the current consumption. 300 milliamps. Oh, it goes to current settings. So I'm increasing to 1.3 amps. Let's try that. It looks promising. Yes, it works. It works. Ha! I did it. Oh yes. Yes. Everything works fine. Everything works fine, and the current consumption is roughly about 600 milliamps, 380 milliamps of current. Anyway. Oh, that was crazy. Oh, that was crazy. Yes. So guys, I hope you enjoyed this video. That was really cool. Cool repair. I hope you enjoyed with that video. Bye bye.